Welcome back to the class, guys. In the previous class, you have seen the physical address of a machine. Physical address is a permanent address. It is given by the manufacturer of the device, and the logical address of a machine is an IP address. So what is a logical address? Logical address is a virtual address. It is generated by the CPU of a machine and it is not permanent. When you change the network, when you are connected from one network to another network, the new IP is generated accordingly. As you can see in the slide, we have 4 devices over here: desktop, laptop, mobile and a networking device, switch in this case. So in the earlier class, we have talked that each device has different network interfaces and has different physical addresses. Like laptop have 3 physical addresses, that is one for Ethernet card, another for Wi-Fi card, the third for Bluetooth. Similarly for mobile you have 2, and for switch you have multiple Ethernet ports and have different MAC addresses. So for each physical interface, a separate IP address is assigned. So what is the IP address? IP address is a logical address. It is a unique string of numbers, basically binary numbers that are separated by a dots, also called as periods, and it is used to identify devices on IP network, both on private networks and public network, that is internet. So IP is a 32-bit binary number for IP version 4 and is a 128-bit binary number in the version IPv6. When we say IP stands for Internet Protocol. What is a protocol? Protocol means set of rules. So Internet Protocol is a standard protocol suite for sending and receiving data across IP networks. Basically, the function of IP addresses is to facilitate networking or establish and facilitating internetworking. And here you can see the example of an IP address: 192.168.10.9. It is a decimal format or decimal notation of IP address. You have 4 numbers separated by 3 dots. And now you can see the 32-bit binary number, which is actual IP address. Since we cannot remember these 32 bits, as humans cannot remember 32 bits and computers only understand ones and zeros, we have converted these binary digits to a decimal notation, the above one which you are seeing over here. So below is a binary format of an IP address and above is a decimal format of an IP address. So as you can see in the slide, you have ones and zeros in a binary form, and each one or each zero is a bit, and 8 bits make a byte. This is called as an octet. So IP address is made of 4 octets or 4 bytes, and each octet has 8 bits binary numbers that ranges from 00000000 to 11111111. So IP ranges from 0.0.0.0 to 255.255.255.255. How this calculation was made? If you look in the slide, we have an IP address example both in binary and decimal notation form, and since computers understand only zeros and ones, if we turn off all the 8 bits in one octet and in all octets to 0, we are taking an example of one octet over here. If we turn off all the bits, obviously it's all zeros, okay? And if we turn on all the bits in 8-bit, that is one octet, and since computer understands binary form only, you have to give the power of 2's in order to calculate or convert binary to a decimal number. And if we take the first bit right side, 2 power 0 is 1, 2 power 1 is 2, 2 square 4, 2 cube 6, 2 to the power of 4 is 16, 32, 64 and 128. So when you calculate all the bits, it makes 255, as you can see. So each octet has number between 0 and 255, and 4 octets ranges from 0.0.0.0 to 255.255.255.255. So let me repeat again. One octet ranges from 0 to 255 only. The second octet ranges from 0 to 255 only. Third octet and fourth octet similarly ranges from 0 to 255 as well, making an IP range starting from 0.0.0.0 to 255.255.255.255. So IP makers sat in a room and decided to make a 32-bit binary number as an IP address, and if you calculate 2 power 32, that makes 4294967,296, that is 4,294,967,296. They thought that world had enough IP addresses for next 100 or 1000 years, because they might not have imagined that the world would make smartphones, tablets, laptops and devices that can be connected to internet, like Internet of Things and so on. So this was very huge number at that time. 4 billion was a very huge number at that time. But now the world population is 7.9 billion. In my home alone, I am using 2 mobiles, an iPad, 2 laptops. My wife has a mobile and a laptop. My daughter has a mobile. My small other kid does not have anything, of course. She is too young. And my father and mother have mobiles each. So we in home have more than 10 devices that are connected to internet. And the world population is nearly 8 billions. Assume at least half of them are using internet, having devices like smartphones and tablets. And if you calculate, at least 4 billion people have 1.5 device. Half means, in here I am not talking one person having 2 devices. I am talking or taking an example of 2 persons having 3 devices. And if we calculate roughly, the world have more than 6 billion devices, and we have only 4.2 billion IP addresses. But don't worry, we humans are smart. We have found a way to solve this problem, which we are going to learn in this class. So how do we look the IP address in our machine? Simply open Run, Windows R on your machine, and type cmd. This will open command prompt terminal. This is a command prompt, and type ipconfig. And this is your IP address that is assigned to Ethernet adapter, and this is the IP address version 6. This is IP address version 4. This is IP address version 6. This is subnet mask. We are going to learn about subnet mask, and this is the default gateway IP address. Okay, this is a Kali machine, and in Linux based machines, open the terminal and type ifconfig to know your IP address. ifconfig, enter. And inet, this is the IP address 10.0.2.15, and this is the subnet mask, and this is the broadcast IP address, as you can see. And inet 6 is IP address version 6 for this Kali Linux machine. So let us go back to the slide. We had a problem with 4.2 billion IP addresses, which were not enough for the population that the world have now, and it was solved by dividing the IP addresses. So we have 2 types of IP addresses, public IP address and a private IP address. So what is public and private IP addresses? The terms public and private IP addresses are assumed based on the network location where your device is connected. That is, the location of network where an IP is assigned into the networking device or a network device. Private IPs are assigned to private networks or local networks, and public IP is used outside a private network, that is in a public network or a internet. So public IP address can be defined as an unique IP address over internet and is assigned by the ISPs, that is internet service providers. As you can see in the diagram, the cloud is an internet, and ISP, you are getting the public IP directly to your device from the ISP. ISP guys, internet service providers, buys a lot of IP addresses and they assign to you when you take internet connection from them. So we are going to discuss about this in a short time. So what is a private IP address? As you can see in the slide, private IP address is not unique IP address and is assigned in a local network or a private network. When I say it is not unique, say for example I have 192.168.10.1, you may have the same private IP address somewhere on the other side of this globe in a local network or a private network. So if you see an example, this is a cloud which is an internet, and from the service provider I am taking a internet connection, and if I add a router like a home router, then it gets a public IP address. And if I connect all the devices like phone, like a smartphone, laptop, or a desktop using a cable connection, then you will get private IP addresses from this router, in which you have a DHCP, dynamic host configuration protocol, that have pool of private IP addresses that you can configure using router interface. And from that pool of private IP addresses, when you want to connect to internet via the router, you will get a private IP address. So as we have discussed the types of IP addresses, we have public and private IP addresses. And public is again divided into two types, dynamic IP address and a static IP address. So what is a dynamic IP address? Dynamic IP address is changed periodically. Means when you receive an IP address from the ISP, occasionally or periodically, once in a month, your IP address changes. But on contrary, static IP address remains forever once it is assigned by your ISP. Most servers have static IP addresses, like your web server or email server have static IP addresses, like websites have this static IP address. And again, the static IP addresses are two types, shared IP address and a dedicated IP address. Shared IP address is, for example, you have abc.com a website and xyz.com website. Both can have same IP address, xx.yy.zz.a. It means that a web server has actually an IP address, and all the websites that are hosted on that website share common or a share same IP address. But if you want a dedicated IP address, you have to spend some amount having a dedicated IP address dedicated to your website. Okay. So now private IP addresses. So as already discussed, private IP addresses are assigned to devices that are connected to internal networks or a private networks, like your home or office networks. The devices could be like listed over here in the screen. Could be a phone, smartphone, desktop with a cable connection, Cat5 cable that is connected from a router to a desktop device, a laptop wirelessly connected, and so on. And this is an example of private IP network, in which devices have private IP addresses in a small office or a home office or even big corporate networks. You have an ISP that gives you an IP address which has a firewall in between, and that is connected to a router. And from the router you have switches. From the switches, multiple devices, multiple computers are connected, all having private IP addresses. And we have discussed that IP addresses are unique. Okay, remember, public IP addresses are unique but not private IP addresses. You and I can have same private IP address, like 192.168.10.1 I can have to my device, and same IP 192.168.10.1 is assigned to your device as well. And let us understand how this works. So these are my email addresses which are unique: t13.tirukuvela info kiran.t131. If I give my email addresses like this, can you send me an email? No. Now, can you send me an email to these email addresses? t13.tirukuvela@gmail.com, info@insectechs.in, and kiran.t131@yahoo.com. Yes, now you can definitely send me an email, because the first portion.
Thank you for watching the video, and do subscribe to the
ID,
YouTube channel.
And the
INSECTECHS.
other portion is email server. So you have two parts in the mail ID. One is unique user ID, the other is email server, on which I have created my email account. Similarly, the IP address also have two parts, like your unique ID and email server in this example. So you have network ID and a host ID part. So in order to send or receive data, you have to identify a device on a network using an IP address, and that can be done by dividing an IP into two parts. One is network part, the other is a host part. Network part recognizes the network to which your device is connected, and once a data reaches to your network, the host ID portion recognizes your device, your particular device, to send and receive data to your device. So as you can see in the slide or screen, 192.168.10.11 is the IP address, and 192.168.10 is the network part or a network ID, while the 11, number 11 is a host ID or a host portion of the IP address. We have first 3 octets, 192.168.10 is 24 bits and the 11 is 8 bits, and the network portion, which is 24 bits, is denoted by /24 notation. So this is called as a subnet mask. So in order to identify a network portion of an IP address, subnet mask is used. So subnet mask is a notation to identify a network portion in a 32-bit IP address. In here we are taking an example of IP version 4 only, not IP version 6. So subnet mask is a slash notation that is used to identify network ID. Subnet mask can be represented in dotted decimal format also. So what is a dotted decimal format? The IP address that human can read is a dotted decimal format, 192.168.10.11, and the subnet mask in a dotted decimal format is something like 255.255.255.0, and this is because the first 3 octets are network portion, and to identify that, the first 3 octets, that is first 24 bits, are turned on in order to identify the network portion, and if we turn on, all bits become 1, and as you know, when you convert from decimal to binary, you will get 255 as a number in an octet. So when communicating on IP networks, IP address alone cannot get the data. It has to be with the subnet mask in order to reach the destination network by identifying the network portion of an IP address. When the data receives to the network, then the host portion will send the data to the connected device. So here are the few examples of IP addresses with the slash notation subnet mask: 192.168.10.15/27 /8 /16 /18 and /32. Can you identify which of these notations are correct? Pause the video, take a time and tell which of these slash notations are correct. All are correct, including the last /32. So let me take the example of the first IP address, which is 192.168.10.15/27. If you convert this IP address from decimal format to binary format, you will get 192 as 11 6 zeros, 168 as 10101000, 10 as 00001010, and 15 as 00001111. By the way, converting a decimal number to a binary number is fairly simple. As you can see in this slide, if you want to convert 168 to a binary number, use this chart and let's turn on the first bit, that is on the left hand side, to 1. If you turn on the first bit, then the number is 2 power 7, which is 128. And if you turn on the second bit, then the number would be 64, and if you add both the numbers, that becomes 192. And 168 is lesser than 192, so you will not turn on the second bit. So you have to turn on the third bit now. If you turn on the third bit, the number would be 128 plus 32, which equals to 160. So we need 8 more numbers. And for that, you cannot turn on fourth digit because it is number 16. So let us turn on the fifth bit now. If you turn on the fifth bit, that is 2 to the power of 3, that is 8, then 128 plus 32 plus 8 becomes 168. So this is how you can convert a decimal number to a binary number. Now coming back to the previous slide, I have converted the decimal IP address to a binary format. And in here, I have to identify the network portion and the host portion. In this example, we have /27 as a notation. So we need to turn on first 27 bits. But we have only 24 bits in 3 octets, 8 plus 8 plus 8. You have to borrow 3 more bits from the 4th octet. So remaining bits will be the 5 bits in the 4th octet. So total 27 bits of 32-bit binary IP is a network portion, and remaining the 5 bits becomes the host portion of a IP address. So let me take another example. In this example, we have an IP address 192.168.10.15/8. /8 means the first 8 bits of 32-bit binary IP will become a network portion. Remaining 24 bits become the host portion. And that in a dotted decimal format will be 255.0.0.0 because we are turning on only 8 bits to identify the network portion. That becomes 255.0.0.0. And for 16/16 we have to turn on first 16 bits as to identify the network portion, and so on. And in this example we have /18 as a notation for the subnet mask. So first 2 octets becomes only 16 bits. We have to borrow 2 bits from the third octet. So remaining 14 bits becomes the host portion or a host ID. And in this particular example where the subnet mask is /18, so first 2 octets become 255.255. Since we are borrowing 2 bits from the third octet, turning on first 2 bits in third octet is 128 plus 64. That becomes 192. So the subnet mask becomes 255.255.192.0, meaning the 18 bits are donating as a network portion. So here is a question. What is the subnet mask in dotted decimal format for the IP address 192.168.22.7/22? Please do this as a homework. Now IP address classes. A while ago we have discussed or we have learned that IP address range starts from 0.0.0.0 to 255.255.255.255. So all these IP addresses, which are 4.2 billion IP addresses, have been divided into different classes. Class A, Class B, Class C, Class D and Class E. You can easily remember these classes: A for apple, B for ball, C for cat, D for doll and E for elephant. So that's funny guys. Anyway, so all these IP addresses are divided into 5 different classes. The IP address range of Class A starts from 0.0.0.0 to 127.255.255.255. Class B 128.0.0.0 to 191.255.255.255. C 192.0.0.0 to 223.255.255.255. Class D 224.0.0.0 239.255.255.255. and class E finally 240.0.0.0 to 255.255.255 and 255. First 3 classes, that is from starting IP address 0.0.0.0 to 223.255.255.255 are host addresses. It means that these IP addresses can be assigned to any device on an IP network. Class D is used for multicasting purpose, and class E is used on experimental basis, sometimes for military use also. And if you see the bottom chart, the network portion of a class A IP address is 8 bits. The network portion of class B IP addresses is 16 bits. The network portion of class C IP addresses are 24 bits, as you can see right side over here. And in a dotted decimal format, it's 255.0.0.0 for class A IP addresses, that is the subnet mask, and similarly for class B and class C, you can see on the slide. And when you borrow bits from the other octets, from the neighboring octets, if you need /18, you have to borrow 2 bits from the third octet. Then such kind of subnet mask is called as variable length subnet mask. Earlier we have discussed the private IP addresses. Public IP addresses are unique and cannot be assigned if once assigned to any other device, but private IP addresses are not unique. You and I can have same private IP address, okay, as you can see in this slide. Top left corner you have private network where you have IP address 192.168.1.11 is assigned to a host machine which is connected to a switch, and down in different network in different ISP in a blue color has a laptop connected with the same IP address. And if I send a message from this laptop which is in blue color down below network to this top red machine which is connected to a switch having same IP address, I can send a message and there can be a data exchange between these two messages in spite of having similar IP addresses. So this is the beauty of private IP addresses. And even private IP addresses are again classified into different classes. As you can see in the slide, private IP addresses are certain range of IP addresses that are reserved by IANA to use on local or private networks only and cannot be used or assigned to devices that are connected to a global internet. Again, the reserved range of these IP addresses are classified as we have discussed: Class A, Class B, Class C and D. As you can see on the screen, Class A starting IP is 10.0.0.0 to 10.255.255.255.255, and you can denote this IP range as 10.0.0.0/8. Similarly, B 172.16.0.0, 172.31.0.0, and the subnet mask is 172.16.0.0/12. Class C 192.168.0.02, 192.168.255.255, and it is a Class C, and the subnet mask notation is 192.168.0.0/16. And this guy, Mr. Jonathan Bruce Postel or John Postel, has designed or classified these IP addresses into different classes. Particularly Class B is annoying for most of the people because newbies don't remember this Class B range 172.16.0.0 to 172.31.0.0, and nobody knows why he has chosen private IP addresses range starting and ending IP addresses as shown over here. And the sir, Mr. Jonathan, has expired in 1998. Mr. Jonathan Postel is a computer scientist and also an executive board member of IANA. As you have learned, IANA is Internet Assigned Numbers Authority, which is actually responsible for maintaining and collection of registries and critical in ensuring global coordination for DNS root zone. Anyway, small revision again. Subnet mask is a logical division of IP addresses, or a subnet mask is 32-bit representation of network and host portion in IP address. Network ID is portion of IP address that identifies TCP network on which host system resides. Host ID is host portion of IP address that uniquely identifies a host in a given TCP network. Host IP is assigned to any device that is connected on a network, could be global network, that is internet or a private network. And broadcast IP is an IP address that is used to send broadcast messages to all the systems that are connected in a network or a subnetwork. Now let's have a small discussion on Internet Protocol version 6. As you know, the IP version 4 has 4,294,967,296 IP addresses, which should have been exhausted by now if private IP range were not designed. However, keeping the future requirements in mind, with the development of technology, increasing number of gadgets, increasing number of connectivity, IP version 6 has come into existence. Even though we are now using IP version 4, we are also getting IP version 6 to the devices that are connected to internet. By the way, what has happened to IP version 5? Because after 4, the number should be 5. IP version 5 was proposed and it was given under RFC 1190, request for comments 1190. You can search on internet for that. And the proposal was just a proposal. She did not accepted him. Anyway, funny guys. So we are discussing about IP version 6 over here. As we discussed in the earlier section of this video class, IPv4 is 32-bit, but IPv6 is massive 128-bit unique identification or unique representation of an IP address, which is of total 8 hextets, that is hexadecimal representation. So we have 4 octets in IP version 4 and the octet have 8 bits, that is a byte. But in here we have 8 hextets, hexadecimal representation to identify device on a IP network. And this is a scary format of an IP address version 6. I did not even convert it to a binary format. This is just a hexadecimal representation of IP version 6. Don't get too much scared. We are not going deep into IP version 6 because internet has not totally converted from IP version 4 to 6. We are still using IP version 4 IPs, and If you have IP version 6 assigned to a device, it cannot communicate to a IP version 4 device. Anyway, let us compare the IP version 6 with the IP version 4, and the left hand side you have IP address 192.168.10.15 which has 4 octets, and here this is an hextet in IP version 6. This is the first hextet, second, fourth, 7th, 8th, 3rd, 6th and 5th. These are all the hextets, total 8 hextets. And in IP version 4 we have 32-bit binary, that is 2 power 32 makes 4.2 billion, and however in 128-bit hexadecimal in IP, if you convert this above hexadecimal IP version 6 to a binary, I have not converted the above IP to a binary, however it will become 128-bit big number. And can you even guess how many IP addresses can be created using this 128-bit IP version 6? Just pause the video and calculate 2 power 128. Got the answer? Look at the screen. Scary, right? Very scary. You cannot even count that number. It has total 39 digits in that number. 39 digits in that entire number. But I have tried using a place value system to tell you what this number is. 340, I don't know what is that. 282 decillion, 366 nonillion, 920 octillion, 938 septillion, 463 sextillion, again 463 quintillion, 374 quadrillion, 607 trillion, 431 billion, 786 million, 211,456 IPs can be created using Internet Protocol version 6. And finally, I saw the God. That's a very big number. And have you seen a movie, Valerian and the City of 1,000 Planets? Even alien races from different planets comes to Earth and connects to our networks. These IP addresses are more than sufficient. So that is a small description on IP version 6. So that's it in the class, guys. Let's meet in another class. Have a great day.
Thank you for watching the video and do subscribe to the YouTube channel INSECTECHS.